Alright, what I've got here is all I'm gonna do is I'm gonna work through each problem of the linear or nonlinear probe that you guys worked on in class. And what you're gonna do is any question that you missed as you went through this probe, you need to watch this video, watch that problem on this screencast, and then go back and rework the problem. Just want to clear up any questions you may have or anything like that. So let's just go ahead and get started on this. Alright, on the first one, it says, which of the following tables represents a linear relationship between x and y? What I have to know about linear is when I see these tables, if it's going to be linear, it's going to have the same rate of change. In other words, everything on x will have the same rate of change, which means it's going to have either plus or minus the same thing over and over again. And then your y has to have the exact same rate of change. You can't have two different rates of change or have a pattern of multiplying or anything like that when you're talking about linear and talking about rate of change. So in this case, let's look at some of these and kind of figure out which one. If I look at this and I want to talk about rate of change, I know, like I said just a second ago, it has to be plus or minus when I'm talking about this. So when I look at the x first, okay, 2 to 5, well, I know my rate of change is plus 3. Because 2 plus 3 is 5. 5 plus 3. Okay, then I know, okay, if I keep going on my table, the next one will be 11 because it's plus 3. And I can go on and on and on with my x, just adding 3 every time. Now let's look at the y on this. I'm going to change colors. So far, so good, right? Well, if I look at my y, from 1 to 2, well, that's plus 1. Now, if this is going to be linear, when I go to my next rate of change from here, I should be able to add 1 and I would get 3. That doesn't match. So I know a cannot be linear. Is it a function? Yes. But is it a linear function? No. Again, if it's going to be a function, a lot of these just they can be a function. When I look at my x value, my input, I'm good there. There's nothing wrong with it because I don't have any repeating domains, so I can just move on from that. But is it linear? Well, let's look at b. From 2 to 5, 5 to 8, 8 to 11. Again, that stays plus 3. But now let's look again at y. Negative 1 to 0. Okay, that's plus 1. 0, it goes to 2. So that can't be linear. It's a nonlinear function because, again, my rate of change should be plus 1. Then in that case, this number would have been 1 and that one would have been 2. So we can't have that. B is a nonlinear function. So now, let's look at C. 2 to 5, 5 to 8, 8 to 11. That stays the same. So I know, again, plus 3. Now look at my y value. Negative 4 to 1. Well, I have a pretty big jump there. Negative 4 to 1. So I know that's what, plus 5. Then from 1 to 2. Well, if I had that same rate of change, it would have been 6. Again, C can't be my answer, but let's go ahead and look at D just to prove our point and show you 2 to 5, 5 to 8, 8 to 11. And that stayed the same. Now let's look at our output. You've got negative 4 to negative 2. I have plus 2 there. Negative 2 to 0. My rate of change again, plus 2. And 0 to 2. It stayed the same. So in this case, my input, x, domain, whatever you want to call it here, all has a rate of change of plus 3. My output, range, it has a rate of change of plus 2. This one is the only one that's linear. The rate of change stays constant. So if you missed that, you go back and watch this one. But let's go on to number 2. In this case, it says, which of the following tables does not represent a linear relationship between x and y? Here we have to look for the key term here is which one does not represent a linear function relationship. And my horrible lines there. All right, so let's look at the first one. 1 to 3 plus 2. 3 to 5 plus 2. 6 to 8 plus 2. 8 to 12. That's plus 4. Let's put a little star next to that one. We're going to come back to that one. And on top, my domain 1 to 3, 3 to 5. Okay. 2 to 11, you got plus 9. 11 to 20, you have plus 9. Definitely linear, right? So if it's linear, we can mark that one out because it's asking what does not represent a linear relationship. Let's look at C. 1 to 3, 3 to 5. My rate of change stays constant at plus 2. 0 to 3, plus 3. 3 to 6, plus 3. My rate of change stays the same there. So both rate of changes are the exact same, linear. Now for D, you've got 1 to 3, 3 to 5, plus 2. But then you have negative 5 to 0, that's plus 5. And 0 to 5, plus 5. Rate of change stays the same, stays constant. That means it's linear. Again, it wants the one that is not linear. Now we can go back up to the one we marked because we want to test them all to make sure the one we marked here, because the rate of change from 6 to 8 is 2, but from 8 to 12 is 4. So in this case, for number 2, the only one we can use there is A. Alright, moving along to 3. That's awful small. Which coordinate plane contains plotted points that represent the graph of a nonlinear function? Okay, so if I look at all these right here as far as which one does contain plotted points of a nonlinear function, again, I'm looking for which one is nonlinear. You gotta pay close attention to the way these questions are asked, or they'll trick you. Well, let's look at each one of these. Well, I can actually test this. I'm going to do this. I'm going to go to my shapes, because linear, I know, has to be straight, right? Well, let's look at, I'm going to start with D. Is this going to be linear? Sure. You know, you can go straight down, straight line there. Now, B, when I look at that one, I can connect the points, linear. When I go C, connect the points, linear. Now let's look at A. Wait a minute, I can't hit all the points on a straight line. So in that one, I'm actually going to have to make some kind of curved line there. So the only one that's definitely a non-linear function that would be, again, A. Is if you see all the rest of them, you see a pattern. Straight, straight, straight. Curve. Alright. So let's look at number 4. Which table does not represent a linear function? Again, key term here, does not represent a linear function. Well, let's look at them. Let's compare. It's the same thing we did before, just a different look. Same process, and process never changes, just the look changes. Alright, so let's look at the first one here. My rate of change of the x, my domain here, from -2 to -1, I have plus 1, -1 to 0, plus 1 stays the same, 0 to 1, plus 1, 1 to 2, plus 1. Well, we got to look at our y. 7 to 4, again, I have minus 3. And it is important that you put the pluses and the minuses. It helps keep you on track to know which way it's going. Because here we go from 4 to 1, minus 3. 1 to negative 2, minus 3. Again, I look at my rate of change, and it's the exact same. Now, I am going to throw something in there about rate of change. I want you to look and see, ask yourself, what is the relationship between rate of change and slope? So I want you to look at that, and I want you to be able to write that down for me. What is the relationship between rate of change and slope? That's just a little freebie to throw in there. All right, so let's look at the next one. So because we know A can't be it because it's asking which one does not represent a linear function. Well, A definitely represents a linear function. So let's go on down to B. Again, your domain is the exact same. Negative 2 to negative 1, 0, 1, 2. I'm just going to put one big plus 1. But if I'm doing it, I'm actually going to show each one of them. But let's look at the y. You've got negative 5 to negative 2. Well, in this case, you're adding 3. Negative 2 to positive 1 plus 3. 1 to 4 plus 3. And 4 to 7 plus 3. Rate of change, constant. Rate of change, constant. That is linear. All right, so let's look at C now. Again, it looks like my domain is the exact same as the other ones. Plus 1, plus 1, plus 1, and plus 1. Now the range on this one, you have from 4 to 1. Well, 4 to 1, that would be a change of minus 3. Then you have 1 to 0. Well, that's minus 1. 0 to 1 plus 1. And 1 to 4 plus 3. Now there's something kind of different about this one as from all these, both of them that we did before. My domain, the rate of change is constant, but my range, it is not. So let's put a little bit of a star there. We'll come back to that one because that could be our winner there. Again, my domains, exact same, adding 1 every time. Negative 2 to negative 1, you add 1. Negative 1 to 0, plus 1. 0 to 1, plus 1. 1 to 2, plus 1. So in this case, I actually have a rate of change that is constant, and the exact same rate of change on both sides, but it's definitely constant. That cannot be my answer because, again, it's asking for which one does not represent a linear function. So let's look back at this one. My rate of change domain was all the same. It was constant. Good to go. But my range, look at this. I have minus 3. That's one reason it's important because then you have minus 1. Then you have plus 1 and plus 3. That's a cool pattern, but it is not a linear function. So in this case, C is going to be my answer. All right, I just have one more of these that was on your probe, and this one, it's which of these equations could be described as linear? And this one can be tricky, or we could look at this one, and really this is on a test. This is one you can just look at and know without doing one bit of work. Because when I look at this, and I see that I have an exponent above the x, that tells me that that's going to be nonlinear. Because if you put just x squared in your calculator, you'll see it is definitely not linear. But you say, well, there's an exponent here, but the difference is where it's located. This one, I could rewrite and say 2x plus 5y equals 9 because 3 squared is 9. when I put that in slope-intercept form, here I'll go ahead and do it real quick. Minus 2x, that's going to leave me 5y equals negative 2x plus 9. Divide everything by 5. Y equals negative 2/5 x plus 9/5. That's linear. It's in slope-intercept form. So here, when I look at this one, I got to look, where's the exponent located? If it's over a number that can be squared, that's fine, because 3 squared is 9. But when I look and I see it over the x, that tells me nonlinear right off the bat.